we only do a couple of lessons of matrices in this class, but the world of matrices is an entire field or an entire like topic of mathematics on its own. So like in college, there will be an entire course for just what we do here. It's called linear algebra. If you've ever heard that term, linear algebra, it basically deals with matrices. What we do here, you don't really learn. There, like this is like the very basic introduction, but you know, there are like multiple applications. One, like I said, in coding everywhere, and then if you get into like quantum mechanics and physics, like there are matrices everywhere. If you've taken chemistry and if you've learned like, you know, like the NLMS, like the angular, right? Have you guys? No. Okay, so those are like the orbital numbers. Those are all like, you know, forms of matrices and stuff.
I know what
so
that is.
yeah. Okay.
Oh.
So let's move on here. So a matrix, what is a matrix? A matrix is a rectangular array which includes variables and constants, and they are arranged in rows and columns, just like we have, you know, the desks here, right? The matrix itself is always enclosed in brackets. It's not just like random numbers in the air. Each value or entry or whatever in the matrix is called an element. Until recently, it was also called, like, they were also called entries. So entry or element. Okay. So take a look at this matrix here. So first of all, to name a matrix, you need a capital letter. This specific matrix is matrix A, right? And you'll, like, when you're referring to it, you'll just say capital A, blah, blah, blah. Okay. Now, do you see how there are different rows and columns? So let's see how many rows there are here. There are 1, 2, 3 rows, right? So the rows are horizontal. In the world of matrices, the rows always come first. And how many columns does this have? 1, 2, 3, 4. Okay? So 3 rows and 4 columns. Now, if we want to talk about the size of a matrix, first of all, we don't say size, we say dimensions of a matrix, and it's always the number of rows and the number of columns. So for example, look, 1, 2, 3 rows, 4 columns. So I would say the dimensions of A is 3 by 4, okay? We always use that X symbol, and it's read 3 by 4. Never 4 by 3, because that would look completely different, right? It's always rows and then columns. And then the, you know, symbols for them, it's M rows and N columns. So we always say like an M by N matrix and so on. Okay, so take a look at this matrix A over here. We first have to state the dimensions of A. So how many rows? 2 rows. And how many columns? 3. So this is a 2 by 3. Now,
That's the multiplication sign?
Right, it's just the X symbol, correct. So now let's refer to the elements themselves. Each of these are referred to by their position, right? So imagine if in this room, instead of referring to you by your names, I refer to you by your seats. So for example, you know, I said, okay, row 3, column 1, you know, like, okay, go ahead, you know, or I said like, you know, row 1, column 3, go ahead, right? That's how we refer to them. So here, if I have a matrix A, then each of the elements, so for example, this element here will be little a and its position. This is row 1, column 2, right? So that's how you refer to that. It's A1, 2. So take a look at this one here, the bottom one, -8. You see that number? That's in the position of row 3, column 2. So its name is A32, okay? So going back here to B, for this matrix A, we need to find the value of A, 2, 3. Which one, what number is that? Negative 8. So second row, third column is negative 8. Right? Okay. This way, it's like very systematic how you can like refer to these. Okay, so we have some matrices with special names. A row matrix, surprise, surprise, is a matrix with just one row. So this is a row matrix. It could be any size. What would the dimensions be of this matrix? How many rows?
1.
How many columns?
4.
4. So that's a 1 by 4. Okay? All right. A column matrix is a matrix with one column. So what would be the dimensions here? 2 rows.
2 by 1.
2 rows, 1 column, 2 by 1. Okay. A square matrix is a matrix that has the same number of rows and columns. So here, what are the dimensions? 2 by 2. Okay. A zero matrix is a matrix of any size, but every single element is 0. So what are the dimensions of this?
2 by 3.
2 by 3. So on a quiz, let's say, I might ask you to write down a 4 by 5 zero matrix. Then you just create 4 rows, 5 columns, zeros everywhere. I might ask you to write, a row matrix of zeros or something. You know what I mean? Okay. So moving along. An identity matrix. What is that? An identity matrix is a square matrix, first and foremost. Okay. In this square matrix for an identity matrix, look at this. If you have a square matrix, this is the first element, right? Row 1, column 1. If you start with that and go down the, diagonally, this diagonal starting with the first and going this way, this is called the main diagonal. Okay, this is the main diagonal. In an identity matrix, you have a square matrix. The main diagonal is all ones, everything else is zeros. Okay, so this is the main diagonal, right? So identity matrix, this is going to be significant later on. An identity matrix is a square matrix. The main diagonal is all ones, everything else is zeros. Okay. Let's talk about matrix operations. So how to add and subtract matrices. This is the most straightforward thing, and it's very straightforward. So to add and subtract matrices, first and foremost, you can only add and subtract them if they have the same dimensions. 3 by 2, 3 by 2, identical dimensions. What you do then is this. You basically match corresponding terms and you add them. So this is row 1, column 1. You match it with row 1, column 1 here. You add them, and the sum goes in row 1, column 1. All right? Okay. Let's just do an example. So take a look here. For each of the following, you have matrix A, B, C. We're going to answer the questions. So first I have A plus C.
You can't do that.
You can't do that, so you just say not possible. B minus A, okay, that you can do, so let's just go ahead and write them. If I were to give you any advice, it would be copy down your matrices so that you know what you're dealing with and you could just have things straight, right? So this is B minus A. They're both 2 by 2s, so my resulting is also going to be a 2 by 2, right? Okay, so let's do the first terms. 10 minus 2, that's an 8, right? It goes in that position. Okay, so decide what you want to do next. Let's just go to the right. Negative 2 minus 5, negative 7, that goes there. -3 minus -1, -2, 16 minus 3, 13. And remember to always put the brackets around them. All right? Any questions? No? Okay. All right. Scalar multiplication. Okay. So if you, in the world of matrix, yep.
So you can only add and subtract together matrices that have the same amount.
Rows and columns. Yeah, that's the first sentence on this page, right? That we highlighted up there. Okay? Okay. So, okay, scalar multiplication. So in the world of matrices, you've got all these, entries in a matrix, right? And then you also have like free-floating numbers, right? That are not in matrices. They're just the regular old numbers that we're used to. Those numbers are called scalars. Okay, so in your science classes, you may have heard the term scalar or vector. Yes or no?
Yes.
That's the same scalar as this, okay? There is like a nirvana somewhere where everything is related, right? All of the math that you've learned and all of the, like chemistry and the physics that you've learned, they're all related. Like that's where the beauty of all this comes in. So this is the same thing. So to multiply a matrix by a scalar, again, extremely straightforward. You just distribute this to every single, element in the matrix. So this is going to be -3 times 1, -3 times 5, and so on. So 0, +6, 18, -12. Okay? It's really very, just very harmless. Okay? All right. Now, some of the same operations that apply to numbers also apply to matrices. So for example, you can combine operations. Like take a look at this one. You can do something like this. If you have a matrix A, matrix B, you could do 3 times A minus B, and it's the same sort of thing, right? So let's go ahead and do that. So we're going to do 3 times A minus B. Can we even subtract A and B? Are they the same dimensions? Yes. So this one time, all right, I'm gonna reduce the amount of writing for you guys. Since they're in the same order that we're gonna subtract them, I'm gonna keep them like that. I'm not gonna copy them down. So let's carefully subtract these, right? So 5 minus 1, I get 4. All right, let's go. I'll race you to them. On your mark, get set, go. Oh, look at you guys. Wait, hang on. I'm still working. Okay. All right. Did we get the same thing?
Yeah, no.
No?
I did.
Negative
bottom
one. Oh,
row.
that's -3.
The bottom row, did I make a mistake?
Yeah, the top right
Top
one
right
is
is
-3.
-3.
Yeah, it's -3.
No, it's not.
Negative
Ah.
minus
Oh,
negative.
Oh,
Wait, 1 minus negative, is it -1 minus -2?
it's
-1 minus -2 is 1. Okay. So now, distribute the 3 in there and we get 12, -6, +3, -9, 12 and -12. And this is exactly that. Okay? All right. So next, so far so good, right? Pretty straightforward. So next, here we have A and B. We're going to add 2 times A plus B. Okay? Fine. So first, we're going to multiply 2 times A. So let's go ahead and write that here. 2 times A will be 2, -8, 10, 16, 0, and 10. So this is 2A. Now we're going to add to this matrix B. So let's copy that down. Okay, so I get 4, -8, 7, 15, 4, 11. Okay? Okay, so next one. I'm going to write, next one we're going to do 3b minus 4a. So let's copy those down here. 3b. So 3b, that matrix is going to be, well, 3 times little b and -6, right? Okay, minus 4a. So minus, what's 4a? 12. 4a.
You can't subtract it.
Okay, so now, what are the dimensions of these matrices?
2 by 1.
2 by 1, 2 rows, 1 column.
Is that -6 for the one under 3?
Yes,
Why?
because we're doing 3b. 3 times b. You can sit there, Amber.
You can't subtract and make it.
Okay, but it's okay. It's okay, because we can have expressions. So now, so look, so when we subtract, we're going to get 3b minus 12. And we just write that, 3b minus 12. That's still one term. Okay? And then on the bottom, -6 minus 4a. Okay? And that's it. That's it. So those are 2 rows, 1 column. Okay, yep. Here is this one. The table below shows the highway and city gas mileage of 5 different types of vehicles. Okay? So, and you guys know, like, for example, like this SUV, right? In the city, it's got 23 mpg, right? 23 miles per gallon. On the highway, 25 miles per gallon, right? We know what we're talking about. Okay.
Yes.
So, we're going to organize this gas mileage in a 2 by 5 matrix. Okay. So, if it's 2 by, you see how like it's dictating the way in which you want to like order these, right? So if it's 2 by 5, it's going to be 2 rows, and we're just going to put in the numbers. So 23, 21, 21, 42, 61, and so on. Okay? So this is it. This is now just the data, just the information. But you know, right, that these are the city mileages and these are the highway mileages, okay? Now it says to add the elements in each row and interpret the results. Okay, so let's add the elements in each row. If I were to do that, right, what would I get? So if I were to add 23 plus 21 plus 21, right, what would I get? Can somebody add those for me on a calculator?
It's probably 168.
Okay, thank you.
Did that in my head.
Nice. And the bottom one? $200, right. Okay, so that's what we get, right? Now, when we add all those up, we get a matrix of a 2 by 1 matrix. So now the next question is, do these represent any relevant information? No, not at all, because this is just the sum, like this is just the sum of, you know, how many miles an SUV plus a minivan would get in the city. Okay, like where is that ever going to be useful, right? So in math, right, you can always take numbers and you can do whatever you want with them, right? You can divide them, you can add them, you can do this, you can do that. But it is always important to know which of these operations are relevant and which of these operations are just like nonsensical things, right? So that much for that. So no, not relevant. Okay, now over the course of, okay, and that gets a sad face. Over the course of the chapter, we are going to do several operations with these, and we're going to see, you know, which ones are things that really, like, you know, can be of use to us. Okay, all right, so this is where we're going to stop for this lesson, and your homework is a handout.